So we're going to take a look at healthy lighting and design in buildings, and we're going to take a look at electrical lighting as well as the use of natural lighting and what we want to achieve as healthy lighting in a building. So the aims of this presentation are going to be to get an understanding of all the electrical hazards that can come along with lighting in a building. So that's looking at all the EMF hazards from lighting. So that's everything from the blue light emitted by the light, as well as the AC magnetic fields or AC electric fields or dirty electricity produced. So we'll go through and identify all the hazards. The next aim is to provide a general recommendation on healthy lighting and design. So we want you to be able to look at a design and look at the type of lighting used and be able to make better recommendations and know what the most likely hazards are going to be as well in that design. And then thirdly, we want to be able to provide recommendations for those who have electrical hypersensitivity. So we want to be able to understand the extra steps that might need to be taken when people are extra sensitive, because then we'll have to take a look at the dirty electricity and electric fields a lot more. So we'll go through that as well. The limitations are going to be that we're not going to show how to test for the lighting spectrum or the flicker rate, etc. There's going to be general recommendations and general kind of rules about which lights emit what. So really to know you need to test, but there's definitely recommendations you can make without using these meters, and we'll go through that. The second limitation is you won't be able to provide a comprehensive lighting assessment and wiring plan for someone with EHS. You might need somebody with a bit more experience, especially if you're just starting as a building biologist in building design or EMF testing. So always our primary goal is to eliminate wherever we can. So we want to use the minimal electrical lighting as possible because that's going to minimize the hazards associated with electrical lighting. So essentially optimizing sunlight, especially with design aspects and orientation, is going to be a big key factor. So we'll take a look at that. So all the hazards associated with electrical lighting. Now, we're going to start with AC electric fields created from the power cords. So essentially wherever there's a wire running to a light, there's going to be the potential for that light to be turned on, and there's going to be an electric field associated with that. So we need to know where the wiring goes essentially. Then there's going to be the AC magnetic fields. Now they're created when the light's actually turned on, and you're going to have issues with high electric fields with transformers, especially on the second floor, where there might be transformers on from the lights on the bottom floor, and you might have kids playing on top of that transformer. So doing floor magnetic field measurements, or if you're looking at a plan, knowing where those are placed and how people are going to use that space on the second floor is really important. The other hazard that comes along with two-way switches is high magnetic fields as well, because the active and neutral can be separated, and that can create a high magnetic field throughout that whole room then. So that's something that when you're looking at the plans, you really need to make sure that the active and neutral stay together, and that if you do have the two-way switches, that it just needs to be wired correctly so that those are together on both sides. So radio frequencies are also a big hazard at the moment, especially with the increase in smart lighting. So, people hook up their phones to use Bluetooth to the lighting so that they can either change the tone of it or they can turn them off and on. There's Wi-Fi, there's Zigbee to control lights. There's different types of radio frequency signals, and that's just a matter of looking at the specs of the light to see what they actually emit. Dirty electricity, so the dimmers, bulbs, and drivers. So different lights will have different dirty electricity associated with it, but generally the rule is dimmers are not good to use, so we try to avoid that. So looking at the design aspect of how someone's going to use the room, where they can place lamps and things to actually just turn off main task lights and have lower lighting in different ways than with dimmers is a good start. Blue light, we're going to really specifically dive into blue light because this is one of the main hazards as well that we look at. It's part of the EMF spectrum, and it's emitted in different amounts from different lights. So we really want to look at minimizing that, and we'll go through why in the next slides. and the flicker rate from electrical lighting. That can be quite hazardous to our body, and we can't always see it. So knowing what lights, are more likely to have a high flicker rate is really important. So Li-Fi, this is something to mention because this is something that's going to be coming up, and more people are talking about Li-Fi and its uses. So I'll play a short video to give you an overview of what it is, but it's basically you're sending signals over the light wave because the Wi-Fi is so congested now. So let's take a look at how it works.
Imagine a world where every light could connect you to the internet. Lights in our homes, offices, cars, and even street lights, connecting us to high-speed wireless internet. Li-Fi is high-speed, bidirectional, fully networked wireless communication, allowing us to give the light we use to illuminate our spaces another purpose: connectivity. Li-Fi-enabled LED lights modulate illumination levels to send data like Morse code. This modulation happens so fast the eye can't perceive it. Li-Fi is where light becomes data. Every year, the world consumes 60% more wireless data. Almost all of this is consumed indoors using wireless internet connections that utilize radio frequencies. The space for radio frequencies is becoming oversaturated, resulting in what is known as the spectrum crunch. Eventually, radio frequency technology like Wi-Fi will no longer keep up with demand. However, Li-Fi does not use radio frequencies. It uses the light spectrum, which can open up 1,000 times more spectrum than radio. Li-Fi will be an integral part of the future of wireless networks, such as 5G. Li-Fi, a world with unprecedented data and bandwidth. Be part of the light revolution.
Okay, so that's just a general overview of how it works. Okay, so we're just going to quickly take a look at how you can test light, and this will be something that we're not going to go into too much depth, as I mentioned, but it's something that you can investigate in your own time or do another course to actually test the light, but we can still make recommendations without doing it. So you can get spectrometers that are handheld spectrometers that you can take to assessments with you, and you can take a look at the actual color index, you can take a look at the spectrum that the light is putting out, you can take a look at the flicker rate. They can be quite expensive, so up to $4,000, and you can go higher than that. So they're not always necessary to make basic lighting recommendations, but they can be really handy, especially if you're just not sure, if you're looking at the difference in quality or two lights and you're trying to make a decision. Now the solutions in Australia, they are getting better. There hasn't been much on the Australian market for good lighting, like full spectrum lights, etc. It's a market that's definitely being, it's definitely coming up to where it is in, say, the United States or Canada, North America. They have a lot more lighting options, and you just have to make sure that if you're looking to buy those lights, that they're not the same voltage. You need 240 volts for Australia, which is why we don't have as much available here, and there's more available there. So once they're tested, once people start testing them in Australia, then that information will become available. So you might not need one of these as well. You can get that information from people that do test them. Meters to assess flicker. You can just get meters to assess flicker, which can be around $500. Again, they're not going to give you that much information because you generally will know if flicker is a problem with the type of light that someone's using. Basic flicker is said to be also able to be assessed with a cell phone camera. Now, I've found a lot of, I've done that a lot just to see if it works, and you can get a lot of false flicker rates, and also where you know that it is flickering when we've tested it with a spectrometer, but it's not picked up with the cell phone. So that can kind of give you a false sense of what's actually going on. So lighting terminology, this is just going to be the common terms that you need to know. It's not going to go through all the lighting. So the lux here is looking at essentially the intensity of light. So this is high throughout the day and then lower at night. So to give you an example, the sun is about 25,000 lux and then the moon is 1 lux. So throughout the day, you're getting that intensity of light that you need to perform your tasks, and then at night you want a lower lux. So that's what we want to mimic in our homes. So this is the efficiency of a light source to illuminate a space. So essentially it's just that the more watts you have, the more effectively you're going to light up a space. Kelvins, now this is what we relate to, like the warmth of a light. So when you see either the really cool white LED lights or the warm ones, it's going to have a different Kelvin range. So you could have 4,000 kelvins, which are the really white bright lights that are quite offensive, and you can go down to warmer ones about even 2,000 to 3,000, and that's where you'd want to look at more in areas like the bedroom, etc. But that'll be something we go more into, but that's basically the warmth of the color that you can see from the light. The flicker rate. So the light is going to flicker because it's hooked up to alternating current. So you still have that electricity going to and from on the distribution system, and that is affecting the light even if we can't see it. So even if it's not perceivable to the human eye, it is there. So that can cause a lot of health impacts, and a lot of people can just have headaches and fatigue just from poor lighting, especially in offices where they have really bad fluorescent lighting that causes a lot of flicker, and that can be enough to just to make people really ill in their work environment. So 3 ways that our body senses and uses light. That's through our eyes, through the rods and cones. We've got the receptors there to collect information, which we know. Now the other thing is that we don't realize how much our skin impacts light absorption and how our body reacts to light through our skin, because we have melanopsin in our skin as well, which means that we can pick up blue light and it penetrates our skin as well as through our eyes. So it's just another way that we can, be actually affected by the lighting in our home, which is why it's so important to understand what this blue light is doing to us. So we want to really mimic natural lighting in our homes as much as possible, because we know the impact that it has on the circadian rhythm. So making sure that we sleep at the appropriate times, wake at the appropriate times, and that, obviously regulates so many of our biological processes. And we're really going to focus here on hormones such as melatonin, because that's where there's the most research as well to show its effects on melatonin production. So we really want to minimize the effects of electrical lighting on our hormones. So by taking a look at how natural light essentially relates to the circadian rhythm is a good place to start. So this is just the circadian rhythm, which just means this is where, at 12 midnight, that's the moon there. And as I mentioned, you've got really low intensity of light. So 2 o'clock, you want this to be your deepest sleep. Now this is if we had perfect melatonin production and if we had perfect lighting throughout the day, so our body was just exposed to the natural light and doing what the light told us to do. So 4 a.m. we've got the lowest body temperature. We've got 6 a.m. we start to wake up, and we start to stop making melatonin, so that our body is starting to become more alert, ready for the day. And at 10 a.m. it should be our most alert time. Obviously that changes quite a lot. We might need a few coffees now before we get to that point. But at noon, this is when we're going to have that really high intensity of lux, so the high intensity of light, and that's when we should we should be doing our tasks here. We should be alert. We've got best coordination, fastest reaction time. And then going towards the nighttime, when we start losing that intensity of light, this is when that blue light as well that's in that high intense sun starts to go down. And that's when we have the melatonin secretion. And that's when our body is going to be told from that melatonin secretion that it's time to rest, it's time to relax. We don't need to be stressed anymore. We don't need to be alert. We can start to get ready for sleep and that restorative sleep as well. So melatonin, so as I mentioned, the blue and the violet spectrum suppresses melatonin production. So the International Agency for Research on Cancer has classified it as a probable carcinogen because melatonin is our anti-cancer hormone, and it also plays such a huge role in sleep, which we need to have that restorative effect on our body. So the suppression of melatonin from blue light is greater in children than adults as well, which is obviously a bit of a worry, especially now with so many children using so many devices for homeschooling, etc., and just devices being pushed all the time for online learning. This is going to be a really big area to look at, especially with poor sleep and then learning behavior, learning difficulties, behaviors, all that kind of stuff. So let's specifically look at blue light. Blue light is present in sunlight, as I mentioned, and we have receptors in our eyes and our skin that detect that blue light. So when we detect that blue light in sunlight, that's when our bodies know that we can suppress that melatonin and we can get ready for the day, and we need to be awake and alert and responding to things. So that's here. So our bodies, are attuned to this light here. So you've got that nice smooth spectrum. This is in the morning when, this is telling us to be awake and alert. And you also have a nice balance here of the red light and everything else. So you don't have one intense peak just affecting the body. Where you can see here, so halogens, we'll discuss the different types of lighting, but halogens aren't as bad because you can see that they're a bit closer to the spectrum of daylight, and they don't have a spike of blue, so they're not going to keep us awake at night as much. But you can see here the cool white LEDs. Now this is going to be the light as well that's going to have high intensity. You're going to have high kelvins, and it's going to light a room really efficiently, but you've got this really high spike of blue that's telling your body to be alert all the time. And if we look at sunlight, that's what's waking us up in the morning, so that's why it's such a problem there. Incandescent, you can see this nice beautiful spectrum here, which is really what we want. It's going to have the lowest impact on human health. This we'll get into the lighting specifically, but this is what we'd want in electrical lighting ideally. And this here is just a sleep mode nightlight. So this is one that's made to have no blue light to keep somebody awake, so it doesn't keep somebody awake, and that it can be used as a nightlight. There are products out there available on the Australian market that you can get to help with that. So there's not as many as readily available, but there's definitely little lights and everything that you can get. I have one around here somewhere that I'll grab. Okay. So what is blue light? So blue light is part of the light spectrum. So we're looking at about 380 to 500 nanometers. So it's, it is part of the EMF spectrum, essentially. Electrical lighting spectrum produces around 400 to 500 nanometer spikes. So that's what we're looking at when we saw those light spectrums before. We're looking at everything in this 400 to 520 that we really don't want our electrical lighting to be producing, because that's what's going to keep us awake at night. So we don't want that to be present at night. So from the effects of that being present in our home and our electrical lighting when we're not supposed to be exposed to it, it can cause a lot of biological effects. We've already mentioned the melatonin production and suppression, which is what we focus on the most, but it also suppresses cortisol. It can damage the receptors in our eyes as well and stop the regeneration abilities. So it can have damaging effects on the eyes, especially for people who are using their tablets, who are using their phones, who are using computers all day long. You've got that constant blue light from your screen, and that can have massive impact on your eyes. So some people can really complain that they're getting eye problems really soon, and that's also another consideration for children. If this, damaging blue light isn't filtered out, or if there isn't that sunlight to counterbalance it, then they can get eye problems pretty quickly. And as little as 40 lux can impact the body. Now that is there's different sources that say different things. There's, some people say that a lot lower intensity of blue light can actually affect the body. So we just want to minimize it as much as possible. So sources of blue light, as we mentioned, the sun. So mainly in the morning, and that's where the amount of blue light throughout the day goes down with sunlight. So that's why, we're attuned to that and why we want to mimic that in our electrical lighting. And obviously electrical lighting, which we've mentioned a few times, and different amounts for different types. And obviously devices. So anything that has a backlight. Now, something to think about here as well is display light. So if somebody has a air purifier in the room going all the time, they need that to go 24/7, it's got an LED display, then that can be emitting blue light. Alarm clock radios and all that type of stuff. So anything that somebody has on overnight as a display can still really pump out a lot of blue light. Even if you have a blue light filter on a tablet, but you've got a light on the charger when it's charging, that could be emitting blue light. So we have to look at all those sources as well. So this is just another representation of, the melatonin suppression with the amount of blue light and, the light source. So here we're looking at a really intense 6,000 Kelvin light, and we're just, seeing that spike of blue, and that's what's just telling our body to constantly be alert, and that's where we're getting the 80% melatonin suppression. The compact fluorescent lamps, now this is where you get these really destructive, just really intense spikes of different colors on the spectrum. And again, here we go, the incandescent bulb. So you still have some suppression, you still have, it's still electrical lighting, but it's going to be the healthiest form of electrical lighting. Now really, if you wanted to get down to, if you had someone that was really sensitive as well, someone has to be really sensitive for me to recommend this, but we can, recommend candles sometimes only a couple hours before bed, because that's going to have your lowest amount of melatonin suppression, and that's how we're kind of built to deal with light as well, because we have fires after the sun goes down if we need light. And the OLEDs. Now this is a really healthy lighting option. It's not widely available. There are some more options on the market, but they're extremely expensive. But that's something to note, because I think we'll be seeing more OLED lighting, and as well you can get screens now, and I think the new iPad Pro might come out with OLED lighting, and that would be a much better and healthier option for your eyes then. So we'll go through blue light solutions. So if you can't eliminate all the sources of blue light in a house, which can be difficult, especially if someone's renting, then blue light blocking glasses and lenses can be appropriate, or applications on the devices, on their phones, tablets, etc., to minimize the amount of blue light while someone's using those devices. Blue light blocking glasses. So what you need to be careful of, so here are a pair to use at night, and you can see that they're red. And then these ones that I have on are day blue light blockers, and you can barely tell the difference. So you need to know what type of lens is blocking how much of the actual blue light, and what spectrum range, because they do all have different effectivenesses at blocking the blue light. So the time of the day and the activity that you're doing will indicate which one you need to use. And the blue light in the 400 to 500 nanometer range, as I mentioned before, is the most important to block out. So if you're looking at any of those reports that that show the spectrum and show what's blocked out, then that's what you'd want to be looking for. So here the lens type. So this is where they're clear lenses. So that's like these ones where you're only blocking 10 to 30%. So we're just minimizing it a bit. These can be worn during the day, indoors, when you're on your devices and when you're using things. Usually I'd like to use it in conjunction with an application that is lowering the blue light as well on the device. The yellow tinted lenses, so they're not as dark as this, don't wear outdoors in sunlight, can be worn during the day when indoors or on digital devices. So that's just going to give you a bit more protection. But also when you're out in the sun, you want to be getting that good sunlight. You want the sun to be telling you what to do. Sorry, I mean like your body to telling what hormones at what appropriate time they should be made. So the amber orange lenses, these ones look a bit more amber orange, but they're in between the 90 to 100% range. The red light lenses are really dark, and you don't want to be going out and using heavy machinery or driving with that, because it will block out you won't be able to see color with them, so you can't do things like drive or operate heavy machinery, as I mentioned, because it's quite dangerous. So people really need to know when to use these lenses, and so you'll need to educate your clients on when to actually use them, because a lot of people use the clear lenses just all through the night and think that that's enough to actually block the blue light effects in their home, but it's not. So this is some of the applications that are available for phones and computers. I really like Iris. I find that it tests the best when used. So if someone can download Iris for Mac or Windows, you do have settings on your monitors that you can usually already use, but Iris is really good, and it has different custom settings that you can use so that throughout the day you can minimize the blue light, and then you can have a sleep mode that that's a timed thing, so that a couple hours before bed or in the evening it comes on automatically. Flux is pretty good. Sky Screen for Windows, so you just need to take a look at the compatibility with the operating system. And then with your phone, twilight and night mode is usually there on Androids or Apples. So you just need to take a look at what applications are already on your phone and settings for the screen. And then otherwise you can take a look at the App Store or whatever store you have with an Android or Apple to see what's available. But these are just a few of the recommended ones, which do test quite well. So infrared lighting. So we'll just take a quick look at this because it's something that, in therapies is coming up as a pretty common question. So infrared light is what we feel as heat. It is visible and non-visible light. We've got the near infrared, we've got mid-infrared and far infrared. So they have different wavelengths and they're used in different therapies, which is why when you're taking a look at saunas or anything like that, you'll see some that have near infrared technology and far infrared technology. So they just have different benefits in the literature, and which is why, and there's different opinions on to which is best. So infrared therapies use LEDs or incandescents to promote circulation, decrease pain and inflammation, promote cell repair, enhance detoxification and sweating, and contribute to weight loss. So infrared saunas can be a source of EMF hazards themselves, because there's some that actually claim to be low EMF, but you have to look at what they're calling EMF, because some might have Wi-Fi or Bluetooth that you have to sit in there and actually use that to be able to turn on and off the sauna, but they're calling themselves low EMF because they might have low magnetic fields or low electric fields because they've shielded or put that in a better area, because some infrared saunas can just have a lot of the wiring right under the seat, or where the lights are right behind where the person would sit. So it's not very beneficial if you're in a high EMF a high EMF spot while you're trying to do this rest and repair work with the infrared therapy. So a lot of the far infrared therapy saunas are just basically promoting circulation detox through sweating and weight loss. And then when you get your near infrared lights, that's when you're looking at there's other benefits to that. and that's where you get possibly more decrease in pain and inflammation, and possibly more promotion of cell repair. So the types of lighting, now we want to look at this in terms of, this is also where we want the solutions for low blue light to come in. So we've got all the other solutions for blue light and to essentially block it where we can, but really the types of lighting we put into our homes and having them to be as low blue light and as low in EMF hazards that we can is beneficial, obviously. So incandescent lighting. So this is obviously the types of lights that they were banned in about 2009, or not banned, but phased out because they're not energy efficient lighting, but unfortunately these are the healthiest for the spectrum as we've taken a look at. And this is what you're looking for when you're taking a look at the bulb. So you're looking at the filament and you can see often, I'm not sure if you can see it on this screen, but this is a decorative bulb. A lot of decorative bulbs are still incandescent and you can just clearly see the filaments in there. So as I mentioned, they're not common. They're being phased out in 2009 for energy efficient bulbs. So yes, as I mentioned, this is a decorative one that you can still get from Bunnings. Now these as well, because they have a lot of tiny filaments to create that decorative effect, they can actually not be as healthy. They can have a bit of flicker and stuff. So, there are some considerations there, but they're still much better. And so some salt lamps still have the incandescence in it, which are great. They'll have that or halogens in, and then they're good options for night lights, especially when there's kids and everything. So then your only hazard there is the actual cord going to the light, and where that is. If it's like located right next to someone's head, then you'd want to move it, etc. So yeah, so incandescents are generally pretty healthy, and we'll take a look at some pros and cons. So the advantages of them, as we've seen before in the previous slide, we saw that really nice smooth wave, like the spectrum that it put out, and really low blue light. So it's having minimal impact on our body, which is really what we want to see with electrical lighting. Low flicker rate. Healthiest lighting, as I mentioned, minimal dirty electricity, and it's just a warmer light, so it's just going to help us wind down for the evening. So they're not considered environmentally friendly, but really if you look at the disposal and the manufacturing of LEDs, it can be argued that if you look at the whole entire lifespan of an incandescent to an LED or a CFL, then we know that they're actually not as environmentally unfriendly as they'd have you believe. So shorter lifespan, more expensive to run, which that is a consideration because they're producing more heat. They'll burn out faster. Not as easy to find. And that's where finding the decorative bulbs, you can still find some as well on eBay. But decorative bulbs, you just have to look at, then you want to look at the efficiency of lighting a space, so how many watts it has. So a lot of the decorative bulbs don't have as many watts, and then you're not going to have as much light, and so people will complain about that type of lighting as well. And that's also the case when you get low blue light bulbs that are actually red, then a lot of people just don't like that and can't really cope with that. It is a bit to get used to, so that's where you can have, like, especially with partners, you can have disagreements with lighting as well in that, so that's just something to consider. So when we want to use these, we want to use them, ideally we would want to use them everywhere when the sun goes down, and we wouldn't want to use anything else. But when we're taking a look at how people are going to use the space, we really want these in the bedrooms, we want them in lamps, we want them in a salt lamp if they're going to use that at night. And yeah, so and again, it depends on most people don't like it as task lighting, if you don't have a high enough wattage, and they are harder to find in a higher wattage. But so just don't use the decorative lighting as task lighting, and you should be okay. But the lamps placed around the home, so specifically where someone's going to read on a chair, so taking a look at where people use spaces is really important, or on a desk you know, where someone's going to be working at night, that type of thing. So halogen lighting, now this is something that, you know, when you look at downlights, you can usually have halogen downlights or LED downlights. We're a bigger fan of the halogen downlights because, as we saw before in the previous slides, this has got a much better spectrum and is much less likely to produce blue light and also dirty electricity. So as you can see here, you've got that, you've got almost another encasement. So it's just a little bit different than an incandescent where you'd see the filaments here, but instead you've got another little encasement in that bulb. Halogen downlights, task lights. So if you can't find the incandescents, then using halogens in your lamps as you would for the incandescents is also another okay option. It's going to be your second best option if you can't find incandescents with the right watts for that specific task at night, or for how much light the person needs. So the advantage, low blue light, low flicker rate. The next healthiest option to incandescents. They're easier to find than incandescents. There can be minimal dirty electricity. They're generally a warmer light. So the disadvantages that we need to know about are when you have a lower voltage, you need drivers. So that has a switch mode power supply, which is the SMPS, which means that that's going to create dirty electricity and magnetic fields. So that's where it chops up the voltage and creates harmonics and high voltage transients. And that's where we get that other extra EMF hazard. So, and again, they're not considered as energy efficient as LEDs. So that's a problem, and it can be quite a problem when you're talking to people in building design, builders, electricians, etc., because they can sometimes get really put off that you're recommending something that's not considered energy efficient. So you want to use them again with the task lighting and the halogen downlights. So they're going to be a better option for downlights where you have an area of the kitchen or something like that where you need to have that dedicated task lighting so that you can have good light when you're actually cooking and things like that. So having downlights that can be turned off at night as well. So then you have downlights and then you have your lamps around when you're ready to turn off that task lighting. So compact fluorescent bulbs. So these, you know, they're quite easy to tell what they look like, and I see these quite often still, especially in desk lamps. They're commonly used for task lighting. Fluorescent tubes used for general lighting areas because it's quite efficient, so quite intense, efficient lighting for tasks. Sometimes as downlights, not very often. So the advantage is that they're great for task lighting, that they're really intense and really you can see quite well. So that's why if people like bright, intense light for their tasks, especially at night, which some people do, then this is, you know, they go for that quite a lot. So the disadvantage is really, you can see there's a lot, really high dirty electricity. Now this is one that impact people so much when we test for dirty electricity and body voltage and microcurrent going through someone's body when they're sitting close to that light. It's massive, the difference that it can make by just changing that light bulb. They can also have noise and they can hum, so some people can just complain about that humming noise. They contain mercury and heavy metals, so they're not great for the environment in terms of the lifespan and the fact that that's going to end up in landfill. Possible UV emissions, they take a long time to start up. They have the spikes of the blue and green light. If you remember these are the really, really spiky spectrum, so really intense bursts of specific spectrum of the light. High flicker rate, and worse with magnetic balusters. We don't recommend these at all. So essentially this is something that's really easy. You don't need to test. You can go around, you can take a look at where the CFLs are and automatically you're recommending something else and it will have a huge impact. Light emitting diodes. So these are the LEDs, which are very common as downlights. Most people know what these look like. So generally with the halogens, there'll just be one element, and with the LEDs, there'll be multiple, or you've got that frosted look, and the light bulbs are often frosted like that. So you'll see these most commonly in downlights. You'll see them in task lights. You'll see them security, outdoor lights, battery powered lamps and candles. So then you won't have that alternating current effect, but it'll just be DC. LED strip lighting. Excuse me. So the advantage is that they're cost effective. People like the dimming options as well, and there's such a wide variety. So you've got such a wide variety in terms of kelvins as well, in terms of if you want warm or cool. So the intensity of light can change quite easily with them. So the disadvantages are low voltage ones, again, need the drivers. So they're, the switch mode power supplies, which is going to create that dirty electricity, not considered energy efficient. Oh, sorry. They are considered energy efficient. So we'll just, they are considered energy efficient, which is why they're used so readily. And this is where, I've come across this many times where I'm, making lighting recommendations, and really a lot of people don't like it when they're not considering the health aspect of it, because it's not energy efficient when I'm recommending incandescents or halogens. Large spikes of blue. So we remember the large, really intense spikes of blue that we saw, and we'll take a look at what we can do about that. So when to use task lighting that you can turn off at night. So essentially, if somebody wants LEDs for task lighting, then you'd want to get cooler LEDs, and you'd want to be able to make sure that they can turn it off a couple hours before bed. So then it's just a matter of educating them. Okay, well, that's going to most likely contain high spikes of blue light. That's going to impact your melatonin production. It's going to impact your sleep. So then kind of educating on a better hygiene for nighttime would be best. 75% of lighting in new builds in Victoria anyway needs to be LED lighting. So that's the consideration where I mentioned before when you're talking to people but in building design, and to the electricians and to the people who are working on the project, that they're going to say, well, you actually have to have the 75% of the LED lighting. So then you need to look at, okay, well, is this something that they can put in and then retrofit later, or what can you do with that lighting to be not used in places where it'll be turned on at night, so that you can actually turn it off and use lamps. Red LEDs to block the blue, better spectrum, but can still have poor flicker rates and high dirty electricity. So there are other hazards that come along with those red lights that you can get, and they also, a lot of people don't like the look of that red light, and that's again where I mentioned partners can have disagreements over the type of lighting that they have at night. So lighting solutions. So as we mentioned, we always want to suggest incandescents as the healthiest lighting option. So that's really going to be if you can source the incandescents, and if how the person's going to use that space, because if they're going to use downlights, then you'd want to take a look at that. But if you can get incandescents in lamps around the house that they can use at night, then that's going to be a pretty healthy option. The next best one is halogens, and they're going to be better than your LED downlights. So that's a consideration there if you're looking at the task lighting in kitchens and well-lit areas. Full spectrum lights would be really good to have as well, but they're just becoming available in Australia. So I don't think that there's any good full spectrums on the market at the moment. It's something that's being investigated, and this will be updated as they come out. there are a few lights that we're testing at the moment just to see, what the output is for dirty electricity, the spectrum, everything. So that's going to be something that you have to really watch the space and do some research, continue to do research, because they will get better. High quality LEDs. So this is, generally if you have a high quality LED, a high quality driver, and it's a warm light as well, then you're generally going to have more, less blue light, and you're going to have less EMF problems. You're going to have lower flicker, but that's just, you do technically need to test each light, but that's generally a good recommendation if you can't go for halogens or incandescents. And it would be better even if you did have warm LEDs that were good quality, still being able to turn them off and having a few lamps that had halogens or incandescents is still going to be far healthier. So that was looking at the bulbs, the previous slide, and this is just the drivers. As we mentioned, good quality drivers contribute to flicker rate, or dirty electricity. Really, that's where you're not going to know for sure unless they are tested. So that's where you'd want to go to that extreme if you're making these recommendations for people with electrical hypersensitivity. You may be able to find someone as well, like myself, that might have tested that particular brand, so you can ask around in the community. But that's going to be, good quality is generally going to be better, and then you might need to test that specific brand and driver if the person you're making these recommendations for are really sensitive. So general ambient lighting. So again, this is just general rules. We want to promote as much light as natural light as possible. As we've mentioned many times now, we want to avoid the LED downlights as much as you can, and avoid harsh light and glare. So if you can't source the incandescents, use the halogen bulbs or warm LEDs as your last option, just to summarize. But again, we're always going to go back to using as much natural light for as long as we can in a building. That's easier from the design aspect of it, not as easy when you're doing a lighting assessment and taking a look at a build that's already there that might have poor lighting to begin with, but that's always our goal. So task lighting, so halogen downlights will have a better spectrum but high flicker rate, which is why, I mentioned a few times that halogens are going to be better, but you still need to know that there is a hazard involved there. Halogen downlights are ideal in the kitchen or study. Again, that's where, you need those bright areas for doing a really specific task at a certain time during the day. You're going to come across this as well when you have people that, need to work at night, or who are artists, or who, do some form of like jewelry making or electronics or something where they need really bright light, and that's part of their work. Then that's going to be something that you might want to go into looking at that further, because they're really going to need good light. That's and it really does have the potential to impact them quite a lot if they're using it that much. Lamps placed in areas for reading and study, incandescent or halogen. So we've mentioned that a few times. So that's where looking at how somebody uses a space, what lamps they already have, what they can replace quite easily is a really good place to start. And then if you're looking at the design aspect, getting people to actually think about how they're going to use that space, because then you're going to think about, okay, well, where are you going to put those power points if you know how they're going to use that space? Because we need to remember then as well, if we have lamps, we've got the electric field as well that you're dealing with the cord. So you don't want that cord to be underneath somebody's chair or right beside them. You still want to create a bit of distance from that source of EMF. So blackout blinds is a really useful way to create total darkness in a bedroom, and that can help people sleep as well. So making sure as well that they don't have any devices that have LED displays or anything that's producing possibly blue light in their room, and having the blackout blinds, and then having that really good EMF hygiene before bed so that they're not exposed to any blue light for at least a couple hours before bed is going to help people sleep as well. That's just cover all the lights and alarm clocks. So, you know, you can just even put electrical tape over the displays for things that people don't need, or lights. So if they do have that, if they need that air purifier on, have it as far away from their bed as possible and make sure that the lights are covered. So the warm and cool lights, which I've mentioned a few times with the LEDs. So the warm light is what's ideal and generally will have lower blue light. Again, you know, you need to test to make sure, because different lights will, different brands will definitely have different levels of blue. But they'll be the most ideal ones to go with if you have to go LED. The cool white light, so they're brighter, the more intense light. These are going to be the higher kelvins, and you know, this is going to be where you really need that bright lighting during the day or for tasks. Now the color changing lights, a lot of people are talking about these at the moment, and some of them mimic the sun. They generally have high blue light still, and they also can have dimmers, and they can also have Wi-Fi smart controls in them as well to give the person the ability to change it with their phones. So generally we don't want color changing lights. We'd want to stick to the warm lights, and they're becoming more common. So this is where, you know, this is looking at the kelvins and looking at, you know, what daylight is and the typical, you know, time that we'd want that. So, you know, bathroom, laundry, and this would be more that daylight is more the kitchen as well. Your cool light is your natural light, but that's 4,000 Kelvin, which is still too harsh, really, for anything after dark. 2,000 to 3,000, you know, those are your warmer lights. So they're going to have a similar appearance in, they feel more like incandescents, but you're still going to have that blue light, and you're still going to have flicker, and you're still going to have dirty electricity. So it's just something to note, though, that it feels better as well, though. But they still have those hazards involved. So they're just generally they'll be put in the bedrooms, and they'll be considered sometimes in lighting design. It's usually when people put up the new fast builds, like where they're building a block of units and they're not really thinking too much about, you know, how someone's going to use a house. They're just kind of getting them up to make money. Then sometimes you can have the entire house just with 4,000 Kelvin LED, just bright lights everywhere in the bedrooms everywhere, because they haven't really thought about it, and that's really going to be disruptive to people trying to sleep at night. So design solutions. So this is where we really want to be able to, at the design stage, use as much natural light as possible and avoid any of the big EMF hazards that can come along with electrical lighting. So lighting design, so using strategies to increase natural light will always, you always want to consider how you're going to use a space. Again, it goes back to that discussion with the client to really get them to feel how they're going to use each room, because then you can see, okay, well, where do the windows need to go in relation to the orientation as well of the build? Can solar tubes be utilized so that an area can be well lit easily through a solar tube? Glazing, do you need glazing? Is it going to be too much sun in that, you know, from the north, etc.? Skylights, light shelves, to get the light to back areas of the room to kind of get it so that, you know, it's farther and deeper into the room. And colors can play a big part of you know, how bright a room looks, how much of the temperature from the light is actually held in the room. And the orientation of the building on the site is obviously going to be one of the most important things as well, because that's going to be, you know, how much light is coming into the building from the sun and just from generally where the windows are and the orientation of it on that. So here's a good video on solar orientation and shading. It just gives a really good overview about what we mean about utilizing the sun on the site, because if we can get this right from the beginning, if you do have that opportunity, then you can really you know, use electrical lighting really efficiently and easily. So let's take a look.
Hey, Eric here with 30x40 Design Workshop. I wanted to talk about how architects use the sun to influence their designs, but rather than speak in generalities, I wanted to use a detail from our project to show you how it works in practice. Before we get into the detail, you'll need a little background. One of the most responsible things you can do as an architect is to listen. And that, for me, always begins with the site. The climate, geography, wind patterns, and of course, the sun. Architecture is nothing without light, and it's perhaps the most important organizing force for our work. It's usually where I start my site analysis, by diagramming the path of the sun as an overlay on the site plan, and I'll get into the specifics on how I do this in a minute. The predominant solar orientation, where the most direct sunlight comes from, here in the Northern Hemisphere, is the south. So the more of our building that can face south, the more efficiently we're able to capture and use the sun for natural light and passive heating, and even cooling, as we'll see in a minute. This approach not only saves energy, reducing lighting, heating, and cooling costs, but it's also better for our own health and well-being. For this project, the lot was sloping and rather long, with a neighboring residence close by to the north. The views to the ocean were all off to the east. With an east-facing site like this, you're faced with a dilemma. Do you orient the long axis of the building north and south to give the client the view of the ocean they requested from every room? Or do you deny the water view in favor of a more sensible solar aspect? Truthfully, I wanted it both ways. The solution I designed divided the program into public and private wings, each oriented with their long axes east and west, as you can see here in the site plan. This gave me the long flank of the building to collect sunlight, and I could still orient some of the most important spaces, the master suite, the living room, and a guest suite, toward the water view. The every room has to have a view of the ocean is a common request where I practice. It's one of the main draws of buying a piece of waterfront property, obviously. But I always try to advocate for a deeper exploration of the site and an interweaving of the architecture into the larger whole. This site has many other features to explore in addition to the water view. By using the circulation to stitch the building volumes together, I could continually change the perspective as my client moved throughout their house and their day. Arriving home, they would head east and then south and then east again. And this, combined with a changing horizon line and sets of interior steps which mirrored the sloping site, this allowed each space to capture a different perspective on the site. Now let's dig a little deeper on the impacts of the sun on this specific design solution. The plan is laid out as 3 linear bars, each stepping down with the topography toward the water. An initial approach might be to simply extrude the bar and put a flat roof on it, but this is less dynamic. It doesn't really react to the solar exposure in any specific way. But by picking up the southern eave of the roof like this and adding a glazed clerestory in the void, this became a really efficient device for letting in sunlight on the southern exposure. The higher you can locate a window on a wall, the deeper it will admit daylight into the interior. As we look at the section, you can see another solar advantage of the shed roof. It allows daylight to pass by the roof form and reflect off the taller northerly wing. Because the private wing contained a lot more program than the public wing, 5 bedrooms, a laundry, a library, and a mudroom area, we had to design it as a 2-story volume. The site analysis made it clear that placing it to the northerly edge of the site would confer a number of advantages. It blocked the views to the neighboring residents, it served as a wind block from the harsh northerly winds on the site, and if we made it 2 stories tall, we could use it to help bounce light back to the northerly face of the living wing, as you can see here. So I'd encourage you to think about a diverse range of uses when it comes to sunlight and how it interacts with your architecture. How can you exploit it, understanding that buildings can absorb, block, filter, consume, store, and reflect sunlight? All right, now that you're up to speed on the larger design moves, it's finally time for the details. Clerestories efficiently daylight interior spaces, as we've said, but along with all that natural light comes solar radiation too, which can quickly overheat spaces and make them uncomfortable, which is just the opposite of what we're trying to do with our design. And here's where the details matter. To control the light and heat on southern exposures, you'll predominantly want to be considering horizontal elements for screening. That's because the sun moves from a low altitude in the winter to a high one in the summer. Horizontal objects act like the brim of a hat to shade the building, and it's the high angle sun that presents the most danger for overheating. While the low angle sun is good for us here in a cold climate, we want to let in the winter sun and use it to offset our heating costs. Horizontal elements can include an overhang, a sunshade, awnings, screens, louvers, or brise-soleil. Because our design was so linear, horizontal louvers seemed the most appropriate. Now, we could have just matched the coursing on the siding and called it good, but there's more to it than that. The spacing and depth of the horizontal louvers can be tuned to your exact geographic location. Why not, right? This is where the sun charts come in handy. Now, a lot of people have been asking about these, and I'll quickly show you how they work. There are essentially 4 dates in the calendar year that you care about when considering the sun's impact on your architecture. The solstices in December and June are the points when the sun is at its extreme arc, either high or low. And then there's the equinoxes in March and September. These are the midway sort of transition points between the two extremes. To design the depth and spacing of the louver blades, you'll want to know the altitude of the sun at solar noon for each of the 4 important dates. In this cold climate, we can take advantage of the lower angle of the winter sun for passive solar heating, and our design can keep the higher angle, hotter sunlight out in the summer. Now, there's a really fantastic podcast by the Australian architect Amelia Lee called The Undercover Architect, and she does a deep dive on this topic. I think it's something like a 6-part series, which covers each different exposure and how you might treat it with your architecture, how that impacts design. Now, she's got her norths and souths all flipped around because, well, she's Australian, but seriously, it's really well done. You need to follow her if you're not already. Links are in the description below. Okay, next step is to take these angles and plot these values on your drawing. Remember, the angle is above 0 degrees, which is, for our purposes, the horizon. So naturally, 90 degrees would be straight overhead. So here in Maine, it's something a lot less than 90 degrees. Okay, so these are our values for the important calendar dates. And given these angles, I start with some basic assumptions about my louver design, and then I begin tweaking as necessary to get the intended effect. Now, you can use SketchUp or Revit, and I really like the app Sunseeker and the real-time augmented reality, especially for renovations. These tools will all help you study and understand sun angles much more quickly and perhaps intuitively than sketching it out by hand. But for details like these, I find sketching to be the most tactile and enjoyable way to design. Now, here's what we ended up with for our design. And you can see that it balances admitting ample winter sun and blocking out the high angle summer sun. The rest of the year, I tried to balance it out. And there's some bit of magic between the spacing, material efficiencies, and the depth of the louvers. And for that, you'll just have to play around with it to get it right. The more materially efficient you can be, the less expensive the sun shading system will be to construct. Now, there are a lot of other ways we could have done this, including addressing it from the inside, but the most efficient way to keep the overheating and glare issues from becoming a problem inside is to keep the sun from striking the glass in the first place. And that means an external solution. Now, the last thing I'll mention about the solar design here is that passively heating spaces this way, it allows you to take advantage of the stack effect too if you add operable windows up high, as we did in our Claire story. As the interior air heats up and rises, and we open the upper windows, it sets up a natural convective flow, exhausting warmer, stale air up high and admitting cooler, fresh air down low. All the resources I used and mentioned in this video are in the description below. I hope this helped explain some of the design opportunities the sun can provide. The data contained in solar charts are immensely useful and pretty easy to divine when you know what you're looking for. Smash that like button below if this has helped you in any way. It tells me you stick around to the end, and I so appreciate that. Be sure to follow me on Instagram for drawings, sketches, and studio process images if you're not already. Cheers, my friends. We'll see you again next time.
So considerations for EHS sufferers, they might need a bit more detail because you are going to need to look at the electric fields as well as the dirty electricity from the wiring of the actual lighting. So some people might not be as affected by that, but you know, people with EHS might really need to make sure that the lighting and the wiring for the lighting is as far away as possible. And you might need to consider that they might not be able to tolerate AC power lighting that's powered by alternating current. So they might need a more complex wiring plan or solution with DC options. Now people, if they're not, you know, if they can't design a home with this in mind, and if they don't have the money, and if they do, you know, a lighting assessment, then you might need to consider just not using the lights at night and having battery powered options. So that's where, you know, low blue light shops in Australia do have battery powered options. So you can get things like this, you know, little desk lamp that has low blue light, you know, so and these, because they've got that red filter, they're not that great for task lighting, and you know, some people can complain that they're not that bright, but I find that people who have EHS you know, still are going to be able to put up with this light better because they're not going to have the reactions from the electric fields and dirty electricity that are emanating from the alternating power supply, the alternating current from the electrical lighting. So you can get things like this for at night, or for night lights. You can get LEDs with, you know, that mimic candles. You do need to check these though, or ask in the communities to see if they do have blue light, because they can still have spikes of blue light. So that's where, when you find the solution, or when you speak to somebody that you know, has measured these, and you can, you know, use them a bit more confidently and make those recommendations a bit more confidently. So other solutions for clients with EHS is to use as much natural lighting as possible, which is what we want to do for everyone anyway. You can use backlighting, which illuminates walls reflectively. So that's where using it, you know, behind shelves, or to light walls from the bottom up and have it on the other side of the room can be quite effective, because then the wires and everything, all the hazards that are associated with that lighting, can be as far away from them as possible. Strip LEDs, they can be helpful, and they, you know, that again, you just need to know the amount of blue light that's emitted, and that can be from someone that's actually tested them. Combustion lighting, so, you know, just going to candles, and sometimes you do just need to recommend it. It depends how sensitive the person is, but there are a lot of people who just choose to use candles in their bedrooms at night. Red light torches at night. So these are just a few of the places that you can get that torch that I showed, or this little reading light. Bluelight.com.au. So you've got those red lights, and now you just need to make sure that you understand that you can have other hazards associated with them, even though they're low blue. And that's the consideration, especially with EHS clients, is just knowing all of those hazards that can come along with them. And then that's where you can also get those red lights, you know, the bulbs that are red, which, you know, people don't always love that type of light, but they are options there. So some more solutions for, you know, the flicker rate and being affected by computer monitors is quite a problem. So looking at the OLED lit screens, which I mentioned that I think the new iPad Pros, like really high-end screens, they're really expensive, can have OLED lighting. And that would be a really healthy option. You can also get a BenQ low flicker eye care monitor. So that's just a much healthier option. There's two sizes. I can't quite remember the price, but it's not as expensive as the OLEDs. So that's a really good, anyone that needs to use a computer that has EHS, we'd want wired connections and a BenQ low flicker eye care monitor. Position computers and screens near an open window. Being exposed to red light from the sun will help combat the blue. So if you remember that spectrum that we looked at of the, you know, the nice kind of the spectrum from the sunlight then it was quite, there wasn't any spikes in it. Now it had the red and it also had the blue, and that infrared that's actually in that spectrum is helping counterbalance the damage that can be done to your eyes in the blue. So if you just set up an office that has an open window, now it's better if the window is open because the light is distorted through glass. So you'd want it to be an open window so that you get the actual natural light coming in. The fly screen is fine. It's just we want light that's not passing through a window if possible, because that's really going to help. So to summarize, we really want to make sure that we're using as much natural lighting as possible, and then it's about, using the best types of bulbs that we can, and also really thinking about how people use the space so that we can use minimal lighting at night and, as far away from the person as well as possible. But we really want to make sure that we have a good understanding of what hazards we can put into the building when we are designing, so that we know that when we're using especially if we have a double-story home and we have, if we have transformers for the bottom floor, that if they're, they're going to be impacting the second floor and where people might be spending time, especially for children that are crawling along that floor. Because I've seen bedrooms essentially where, a child might be playing in one spot and it just happens to be right on top of a light for downstairs. So when they're playing and that light's on in the kitchen, that's a huge magnetic field. So it can be like 3 to 4 milligauss right on that spot that the child's sitting, and it drops off quite quickly. So as soon as you move away from it, it's okay. But you really want to make sure that, the placement of those, that you think about how the second story is being used and where you could better place those. And then you've got the electric fields as well coming from those lighting circuits, so that, on that second floor, especially, while they're walking along the floor, there's wires for that lighting underneath that. So can you use shielded cabling to lower those electric fields as well? Things like that. The dirty electricity that's going to come from poor lighting choices such as CFLs, low quality LED drivers, etc. So, having good quality lighting and using low blue lights wherever we can is going to be really helpful. And then a lot of it is, just ensuring that you educate the client on healthy lighting choices, but how to use those lights, and good light hygiene before bed. So if they don't want to take all of your recommendations as well for lighting, or they can't afford it, anything like that, then that's where you go to the blocking blue light, which is, the glasses and the apps and functions on the tablets and devices, any devices that you have around the house. Now you're going to need those anyway, because most people are going to have tablets and computers and phones that they use. So putting those putting those apps on to decrease that exposure is always going to be what you want to do anyway. So hopefully this helps, so that you can start to understand how to make good recommendations when looking at lighting in a building.